Have you ever wondered what lies beneath the vast, icy expanse of Antarctica? Beneath that endless sea of white, beyond the frozen surface you see in pictures, there is a hidden world, a place so remote and untouched that it remains one of the last great mysteries on our planet. Imagine, miles beneath the ice, vast lakes sealed off from the sun for hundreds of thousands, maybe even millions of years. These ancient bodies of water, trapped beneath kilometers of solid ice, are like time capsules, preserving secrets about Earth's past climate, life, and even the forces that shaped our world long before humans existed. The Antarctic ice sheet is not just frozen water. It's a thick, ancient archive of our planet's history, slowly built up over millennia, layer upon layer, each one telling a story of shifting climates, swirling winds, and changes that ripple through the atmosphere and oceans. Beneath that white blanket, hidden by darkness and crushing pressure, lies a landscape unlike any other. Rugged mountains, deep valleys, and lakes so isolated they have never seen daylight or breathed fresh air. These secret places challenge our understanding of where life can exist. Some scientists believe microbes may still survive in these icy depths, tiny survivors adapted to conditions so extreme it's hard to imagine. Studying these frozen mysteries is more than just curiosity. It helps us understand Earth's climate system, the origins of life, and even guides us in the search for life on other worlds like Mars or the icy moons of Jupiter. Tonight, as you settle in, wrapped in warmth and quiet, let your mind drift beneath the Antarctic ice. Imagine descending slowly through the cold darkness, past thick layers of ice so ancient they predate human history, until you reach the still waters of hidden lakes. Picture the faint glow of life in those icy depths. Microorganisms thriving without sunlight, clinging to existence in a world frozen and sealed off. The silence here is absolute. A profound stillness broken only by the faint cracking of ice or the slow movement of glaciers inching forward over the land. There is something haunting and beautiful about this place, a frozen secret waiting patiently for us to unlock its mysteries. Before we move deeper into this journey, I'd love to know where you're watching from and what time it is there. Feel free to leave a comment below. It's amazing to see this quiet community of curious minds gathering across the globe. If you enjoy this peaceful exploration beneath the Antarctic ice, please hit the like button and subscribe. It helps others discover this calm corner of science and lets me keep sharing more soothing stories like this with you. Now close your eyes and imagine the cold embrace of the Antarctic ice, and let's begin uncovering the secrets beneath. Beneath Antarctica's frozen surface, the world is unlike anything you've ever imagined. This is not just a vast sheet of ice. It's a dynamic, living system shaped by forces both ancient and powerful. The ice itself, some of it as much as 4 kilometers thick, acts as a barrier and a protector, preserving what lies below from the world above. But what exactly is hidden beneath this seemingly endless expanse of white? Scientists have discovered a hidden realm of subglacial lakes, rivers, and mountain ranges, a secret landscape locked away under layers of ice that shield it from light, air, and warmth. These lakes, unlike any you've seen on Earth's surface, exist in complete darkness, in temperatures far below freezing, yet they remain liquid because of the immense pressure from the overlying ice. Lake Vostok, one of the largest and most studied of these hidden lakes, stretches over 250 kilometers in length and is buried beneath nearly 4 kilometers of ice. Imagine that, a lake the size of Lake Ontario, concealed from view by ice as thick as Mount Everest is tall. What mysteries could it be hiding beneath its dark, silent surface? Scientists believe that these subglacial lakes have been sealed off for hundreds of thousands, possibly millions of years, isolated from the rest of the world. This isolation makes them time capsules, preserving conditions from Earth's distant past. By studying the sediments and water from these lakes, researchers hope to unlock stories about past climates, ancient ecosystems, and the processes that shaped our planet. But accessing these lakes is no simple feat. Drilling through kilometers of ice without contaminating these pristine environments requires cutting-edge technology and extreme care. The challenge is to pierce this icy shield without disturbing the delicate balance below, so that any samples brought to the surface can offer genuine insights into this hidden world. The mystery deepens when we consider the possibility of life thriving in such extreme conditions. Life as we know it depends on sunlight for energy, but beneath the Antarctic ice, sunlight never reaches. How could anything survive in total darkness, under crushing pressure, and near freezing temperatures? Yet, life is tenacious and adaptive. Microbial organisms, tiny, single-celled life forms, have been found in some of these subglacial lakes and surrounding sediments. These microbes have evolved to live off chemical energy sources rather than sunlight, extracting nutrients from minerals in the rock and water around them. Their existence pushes the boundaries of what scientists thought possible for life on Earth, suggesting that life could exist in similarly harsh environments elsewhere in the solar system or beyond. As we peer deeper into these icy depths, questions emerge about the interconnectedness of the Antarctic subglacial environment. Some of these lakes are linked by rivers of water flowing beneath the ice, creating a hidden network that influences the movement of the glaciers above. These subglacial water systems can lubricate the base of the ice sheet, affecting how it slides over the rocky bed beneath and ultimately influencing the stability of the entire Antarctic ice sheet. Understanding these processes is critical for predicting how Antarctica will respond to climate change and what impact it may have on global sea levels. The study of Antarctica's hidden lakes has opened a new window into Earth's frozen past and its future. It invites us to rethink what we know about life, climate, and the planet's most extreme environments. As you drift deeper into sleep tonight, imagine the silent, dark waters beneath the ice, a world untouched by sunlight, where ancient microbes quietly carry out their lives, undisturbed by human presence or the chaos of the world above. Picture the slow movement of glaciers, driven by forces invisible to us, slowly shaping the landscape over thousands of years. And as your mind settles, remember that these hidden places, so far from our everyday lives, hold keys to understanding the very nature of our planet. So many secrets remain locked beneath that cold, white surface, patiently waiting for discovery. This is the magic of Antarctica, a frozen mystery that challenges our curiosity and our imagination, reminding us of the vastness and wonder still left to explore. In this quiet, remote place, science meets the unknown, and every new discovery is a step into the great unknown. It's a reminder that even in the coldest, darkest corners of our world, life and mystery persist, and with every drill, every sample, every cautious step forward, we inch closer to unlocking the story written beneath the ice. But before we continue, I'm curious, where are you joining this quiet journey from? What time is it where you are? Feel free to share your location and local time in the comments below. It's incredible to think about all of us scattered across the globe, connected through this shared moment of curiosity and calm. If this exploration beneath the Antarctic ice brings you a sense of wonder or helps you drift peacefully to sleep, please tap the like button and subscribe. It helps others find this gentle corner of science and allows me to keep creating these soothing stories just for you. Now, let's move even deeper into the mysteries hidden beneath the Antarctic ice and continue our slow, quiet voyage into a world few have ever seen. Beneath the Antarctic ice, where sunlight never reaches and temperatures hover far below freezing, the environment is unlike anything else on Earth. This frozen wilderness is not just a static, frozen desert. It is alive in ways we are only beginning to understand. Scientists have uncovered entire mountain ranges buried under the ice, some taller than the Alps, vast valleys carved over millions of years, and flowing rivers of water trapped in perpetual darkness. This hidden world is a stark contrast to the barren, white landscape visible from above. What makes it even more extraordinary is the presence of liquid water in these frigid depths. Normally, water freezes at 0 degrees Celsius, but under the enormous pressure of kilometers of ice, the melting point lowers significantly, allowing lakes to remain liquid even at temperatures well below freezing. These subglacial lakes, sealed off from the outside world for millennia, form a network of mysterious bodies of water beneath the ice sheet. The largest and most famous of these is Lake Vostok, discovered in the 1990s through satellite radar imaging. Lake Vostok alone contains an estimated 5,400 cubic kilometers of water, enough to fill Lake Ontario more than twice. Despite its size, it is completely isolated, covered by a thick ice ceiling that has protected it from contamination and atmospheric influence for possibly up to 15 million years. The age and isolation of these lakes make them veritable time capsules, preserving clues about Earth's ancient past and about life's ability to survive in extreme conditions. But drilling into these lakes to collect samples without contaminating them is an extraordinary challenge. Scientists have designed special clean drilling systems to penetrate the ice with minimal environmental impact, working carefully to preserve the delicate ecosystems that may exist within. What might those ecosystems be like? Could life survive in complete darkness, without sunlight or oxygen, under crushing pressure? The question has fascinated scientists and astrobiologists alike. Microbial life has been found in other extreme environments on Earth: deep-sea hydrothermal vents, acidic hot springs, and deep underground rocks. So, it is plausible that unique forms of life could persist in these Antarctic lakes, sustained by chemical energy extracted from minerals in the bedrock and water. The discovery of such life would not only revolutionize our understanding of biology on Earth, but would also provide clues about the possibility of life on other icy worlds, such as Jupiter's moon Europa or Saturn's moon Enceladus, both of which are believed to have subsurface oceans beneath their frozen crusts. The exploration of Antarctica's subglacial lakes is thus an Earth-bound quest with cosmic implications. But beyond the life they might harbor, these hidden lakes and waterways play a crucial role in the dynamics of the Antarctic ice sheet. The water flowing beneath the ice acts as a lubricant, affecting how glaciers move and how the ice sheet responds to warming temperatures. As global temperatures rise and ice begins to melt, understanding the behavior of these subglacial water systems becomes essential for predicting future sea level rise and global climate patterns. There's a poetic eeriness to imagining these ancient lakes, vast, dark, and silent, cradled beneath thousands of meters of ice. They are places where time has stood still, untouched by light or life as we know it. And yet, they are far from lifeless voids. Recent studies of microbial DNA recovered from ice cores and subglacial sediments suggest that unique microbial communities, some of which could be ancient lineages, exist within these hidden worlds. These microorganisms survive by metabolizing chemicals such as hydrogen and methane, products of geological and chemical processes occurring deep below the ice. Their slow metabolism and longevity in such conditions challenge our understanding of what it means to be alive and expand the known limits of habitability on Earth. For those who dream of space exploration, Antarctica's subglacial lakes serve as analogs for extraterrestrial environments. If life can persist beneath kilometers of ice on Earth, it strengthens the hope that similar life forms might exist beneath the icy shells of moons circling distant planets. Exploring these lakes is thus not just a matter of Earth science. It is a step toward answering some of humanity's biggest questions. Are we alone? What forms might life take elsewhere in the universe? As you imagine this, picture yourself descending slowly through the thick, silent ice into a hidden lake where the water is still and black, reflecting nothing but the darkness. Imagine a world without sunlight, without air, where life might cling to existence in ways alien to our daily experience. In this quiet, extreme environment, time feels suspended, ancient secrets preserved beneath the ice. And yet it is not a place of hopeless isolation. It is a place of resilience and adaptation, a reminder that life and mystery endure even in the coldest, darkest corners. Beneath the ice lies more than frozen water and ancient microbes. There are mountain ranges, valleys and plains, sculpted by eons of geological forces. These subglacial landscapes shape how the ice flows and fractures, influencing Antarctica's stability and the global climate. Modern satellite and radar technology have allowed scientists to map these hidden terrains, revealing surprising features such as active volcanoes beneath the ice sheet. These volcanic activities can impact the ice above by melting it from below or by injecting heat and minerals into the subglacial environment, adding another layer of complexity to this icy puzzle. The interplay between geology, ice, water, and life beneath Antarctica is an unfolding story, one that demands patience, precision, and respect for the fragile environments involved. Scientists working in extreme cold, isolated conditions, sometimes hundreds of kilometers from the nearest research station, risk much to peer into these frozen depths. Their work is a testament to human curiosity and determination, driven by a desire to uncover the hidden chapters of our planet's history and the nature of life itself. As you lie comfortably now, perhaps feeling the gentle rise and fall of your own breath, think about the vastness and stillness of Antarctica's hidden lakes. Imagine the slow drip of ancient waters, the microscopic lives that persist in silence, and the vast frozen mountains that hold these secrets close. Let your mind wander to these remote places, far from the bustle of daily life, where the mystery of Earth's frozen depths continues to inspire and astonish. As you drift toward sleep, remember that this hidden world beneath the Antarctic ice is a reminder of nature's resilience, of the unknown waiting patiently just beneath the surface, and of our ongoing journey to understand the planet we call home. And now, before we continue our quiet exploration, I'd love to know, where in the world are you listening from tonight? What time is it where you are? Feel free to share in the comments below. It's amazing to think about all the places this gentle story is reaching, connecting us across distances and time zones. If this peaceful journey into the Antarctic depths helps you relax or sparks your curiosity, please consider liking and subscribing. It helps more like-minded explorers find this quiet corner of science and allows me to keep sharing these calm, captivating tales just for you. Now let us continue our slow descent into the secrets hidden beneath the Antarctic ice, where mystery and science meet in the coldest, quietest corners of our world. As we delve deeper beneath the ice, the world transforms in ways that challenge our imagination. The darkness grows absolute, and the silence is profound, a silence unlike any you have known. Here, sound barely travels, and light is but a distant memory. Yet beneath this frozen veil lies a dynamic world shaped by forces invisible to us on the surface. The ice sheet above is not simply a static wall of white. It flows, bends, and creaks, slowly but relentlessly moving toward the ocean. This movement is governed not only by gravity but also by the hidden topography and mysterious water channels beneath. Imagine vast rivers of water winding silently beneath miles of ice, carving paths through the ancient bedrock, sometimes pooling into deep lakes, other times bursting forth as subglacial floods that reshape the landscape above. These subglacial floods, though hidden from view, can be powerful enough to influence ice flow rates and even trigger sudden glacial surges. The presence of water lubricating the ice-bed interface can cause glaciers to speed up dramatically, a phenomenon observed in several Antarctic regions. This dynamic is crucial because it plays a significant role in how ice sheets respond to warming climates, and by extension, how much sea levels might rise in the coming decades. But how do scientists study such a remote and inaccessible realm? Traditional methods of exploration like drilling or submersible vehicles are incredibly challenging due to the extreme cold, immense pressure, and the risk of contaminating pristine environments. Instead, researchers use a combination of satellite observations, ice-penetrating radar, seismic surveys, and remote sensing technologies. These tools allow them to peer through the ice and map the hidden landscape below with remarkable detail. By bouncing radio waves off the ice-bed interface, radar can reveal the thickness of the ice, the roughness of the bedrock, and even the presence of liquid water. Seismic surveys, where sound waves are generated and recorded as they travel through the ice and underlying rock, help create three-dimensional images of the subglacial structures. Together, these methods have unveiled an astonishing underground world: sprawling mountain ranges, deep basins, ancient river valleys, and pockets of liquid water that defy our expectations. Some of these subglacial lakes may have been isolated for millions of years, evolving unique ecosystems beyond our comprehension. The thought of entire biospheres existing in perpetual darkness, completely cut off from the sun's energy, invites a sense of wonder and humility. What kind of life could thrive in such a place? Microbial life is the leading candidate, and the study of extremophiles, organisms that survive in extreme environments, has reshaped our understanding of biology. These resilient creatures have been found in boiling acidic springs, radioactive waste, deep underground caves, and the crushing depths of the ocean floor. The microbes beneath Antarctica's ice may live off chemical energy derived from the interaction of water with minerals in the rocks, a process known as chemolithoautotrophy. They could form the base of a unique ecosystem supporting other microbial species and perhaps more complex organisms, though evidence for the latter remains elusive. Sampling these lakes is a delicate affair. Scientists must ensure that their drilling equipment is sterile to prevent contaminating these pristine environments with foreign microbes from the surface. The possibility of introducing external life forms raises ethical and scientific concerns, as contamination could irreversibly alter or destroy native ecosystems that might hold clues to life's origins and resilience. This caution adds to the suspense and mystery. Every mission to these hidden lakes is a high-stakes endeavor with potentially profound consequences. Even as technology advances, the unknown beneath the Antarctic ice remains vast. Every discovery leads to new questions. For example, some subglacial lakes appear connected by networks of waterways, suggesting a complex hydrological system flowing beneath the ice sheet. These hidden rivers might influence ice stability and affect how glaciers respond to climate change. Understanding this system is essential for accurate predictions about the future of Antarctica and its impact on the global environment. Imagine the slow, silent movement of water flowing beneath kilometers of ice, shaping the landscape unseen, moving sediment, nurturing life, and influencing the fate of entire ice sheets. This hidden hydrology is a vital piece of Earth's climate puzzle, yet it remains one of the least understood components. Beyond the water and ice, the geology beneath Antarctica reveals surprising secrets. Hidden mountain ranges rise like submerged giants, some peaking higher than the Alps. These mountains bear scars from ancient tectonic collisions and volcanic activity. Indeed, evidence of active volcanoes beneath the ice adds another layer of mystery and complexity. The heat from volcanic activity can melt ice from below, creating pockets of liquid water and impacting ice flow. Such geothermal hotspots might even provide refuges for life in an otherwise harsh environment. The interplay between fire and ice beneath Antarctica speaks to the dynamic forces shaping our planet in ways invisible to the naked eye. Now, let us turn our attention to a particularly captivating mystery: the so-called Blood Falls. At the edge of the Taylor Glacier in Antarctica, a striking waterfall pours blood-red water into the icy landscape. The phenomenon was first observed in 1911, and its eerie color immediately sparked curiosity and speculation. For decades, scientists wondered about the source of this crimson flow. Recent research has revealed that Blood Falls is fed by an iron-rich, hypersaline subglacial lake trapped beneath the glacier. The iron in the water oxidizes when exposed to the air, creating the distinctive red color, much like rust forming on iron metal. What makes this phenomenon extraordinary is that the water is nearly devoid of oxygen, yet it hosts microbial life that can survive in these extreme conditions by metabolizing iron and sulfur compounds. The microbes thriving in this dark, salty, iron-rich environment offer a glimpse into life's adaptability and hint at the possible existence of similar life forms in other harsh environments across the solar system. Blood Falls is a vivid reminder that even in the harshest and most alien-looking environments on Earth, life finds a way to endure and flourish. As you imagine this crimson cascade emerging from the glacier's icy wall, picture the silent microbial communities transforming iron compounds in total darkness, miles beneath the surface. It is a quiet testament to nature's tenacity and a vivid illustration of the mysteries locked beneath the Antarctic ice. As you lie comfortably now, perhaps feeling your body slow and relax, let your mind wander to this frozen world beneath the surface, a place where darkness and silence hold secrets millions of years old, where water flows silently beneath kilometers of ice, where life persists in the most improbable ways. These hidden stories remind us that the Earth still holds mysteries, waiting patiently for us to uncover them, and that our planet's story is far richer and more complex than we can imagine. And now, before we move on, I'd love to hear from you. Where are you joining this quiet journey tonight? What time is it where you are? Feel free to share in the comments below, and if you find comfort or curiosity in these gentle explorations, please consider liking and subscribing. It helps others find this serene corner of science and encourages me to keep sharing peaceful, captivating stories just for you. Let us continue together, slowly and softly, into the secrets still hidden beneath the Antarctic ice. Beneath the Antarctic ice, hidden from sunlight and shielded by kilometers of frozen crust, lies a realm that seems almost otherworldly. It is a place shaped by forces both ancient and ongoing, a realm where time flows differently, where life clings to existence in unimaginable ways, and where the familiar rules of our surface world give way to a landscape of ice, rock, and liquid mystery. Imagine yourself slowly descending into this secret world. As the sunlight fades, replaced by the profound darkness of perpetual night, the ice itself becomes a gateway to a hidden ecosystem, an untouched archive of Earth's history, and a living laboratory of extreme biology. What you encounter here challenges every assumption about life, climate, and the resilience of nature. This hidden Antarctic world is not uniform, but rather a complex mosaic of environments. Some areas are locked in deep, frozen silence, ancient ice shelves that have remained stable for hundreds of thousands of years, preserving a pristine record of the past. Other regions are far more dynamic, glaciers that flow slowly like frozen rivers, deep basins filled with liquid water warmed by geothermal heat, and networks of subglacial lakes interconnected by narrow channels of water flowing beneath the ice. These lakes, sealed off from the atmosphere for millennia, hold water that has never seen the light of day. Scientists believe that within these lakes, microbial communities may have evolved in isolation, developing unique adaptations to survive on chemical energy sources rather than sunlight. The potential discovery of such life forms excites researchers, offering a glimpse into the limits of life on Earth and clues about how life might exist in extreme environments elsewhere in the solar system, such as under the icy crusts of Jupiter's moon, Europa, or Saturn's Enceladus. The study of these subglacial lakes and their ecosystems is not only about biological curiosity, it also carries implications for understanding Earth's climate system and future sea level rise. The movement of water beneath the ice sheet influences how quickly ice flows into the ocean, and sudden releases of this water can lead to abrupt changes in glacier dynamics. These subglacial hydrological systems act like hidden arteries beneath the ice, transporting water, heat, and sediments. By mapping and monitoring these systems, scientists gain insight into how Antarctic ice sheets respond to warming and how much water they might release into the world's oceans over time. This knowledge is critical for forecasting the impact of climate change on global coastlines and human populations. Yet, despite advances in technology, much of Antarctica's subglacial world remains unexplored. The extreme conditions make direct sampling a formidable challenge. Drilling through miles of ice to reach these lakes requires sophisticated equipment and painstaking protocols to avoid contamination. Every mission is a delicate balance between scientific ambition and environmental stewardship. The potential for discovering new forms of life and unlocking secrets of Earth's history comes with the responsibility to protect these pristine environments from human interference. This ethical dimension adds a layer of gravity to the already suspenseful narrative of Antarctic exploration. The sense that beneath the ice, a hidden world is waiting, and we must tread lightly to ensure its survival. The mysteries extend beyond the water and life hidden beneath the ice. The Antarctic bedrock itself tells stories millions of years old. It preserves evidence of ancient climates, tectonic movements, and the formation of continents. Beneath the ice lie mountain ranges that rival those above ground, including the Gamburtsev Mountains, a vast, rugged chain buried under thick ice, unknown to the world until relatively recently. These mountains are thought to have played a key role in the formation of the Antarctic ice sheet and continue to influence ice flow and stability. Seismic surveys and radar mapping reveal intricate details of these submerged peaks and valleys, painting a picture of a landscape both majestic and enigmatic. The contrast between this hidden geological drama and the silent frozen surface above deepens the sense of mystery and awe. Another enigma within Antarctica's icy embrace is the presence of volcanic activity beneath the ice sheet. Active volcanoes, such as Mount Erebus, are known to exist on the continent, but recent studies suggest that volcanic heat sources deep below the ice may be more widespread than once thought. This geothermal heat melts ice from below, creating pockets of water that affect glacier dynamics and subglacial ecosystems. The interaction between ice and fire beneath Antarctica creates a tension that seems almost poetic, a frozen world alive with hidden heat, shaping the continent's past, present, and future. This interplay challenges simplistic views of Antarctica as a static, lifeless place and reveals it as a complex system of forces in constant, slow motion. All these layers of mystery, the subglacial lakes, the hidden mountain ranges, the volcanic heat, combine to create a sense of profound wonder. They remind us that even on our own planet, there are places that remain largely unexplored, places where science and imagination meet in the quiet darkness beneath the ice. The Antarctic is a testament to the resilience of life and the enduring power of nature's hidden forces. As we listen to the subtle sounds of ice creaking, water flowing, and perhaps even the faint whispers of microbial life, we connect with a world that is both alien and deeply familiar. Now, as your body grows heavier with calm and your mind drifts gently toward rest, let the image of this frozen underworld fill your thoughts. Picture the slow, silent rivers beneath the ice, the microbial life eking out an existence in total darkness, the immense mountain ranges hidden from sight, and the fiery heat flickering beneath the frozen surface. These secrets of Antarctica invite us to remember how much remains unknown and how much beauty can be found in the quiet, mysterious corners of our world. And in that quiet, perhaps you find a kind of peace, the peace that comes from knowing the Earth is still alive with wonders, even when hidden from view. As we continue to explore the vast expanse beneath the Antarctic ice, it becomes clear that this frozen realm holds more secrets than any one expedition can uncover in a lifetime. The deep ice sheet itself, extending for millions of square kilometers, acts like a time capsule, preserving layers of snow and air bubbles that reveal Earth's climatic history, stretching back hundreds of thousands of years. Scientists drill deep into these ice cores, carefully extracting cylindrical samples that contain tiny pockets of ancient atmosphere, trapped dust, and chemical signatures. These frozen archives are invaluable for reconstructing past climate conditions, revealing patterns of ice ages, warm periods, and the rhythms of natural change. Each layer is a page in Earth's long, intricate story, a story that has shaped the planet's ecosystems and continues to influence our present-day environment. The importance of these ice cores cannot be overstated. They offer a direct glimpse into how greenhouse gases, such as carbon dioxide and methane, have fluctuated over millennia. By comparing these historical records with modern measurements, scientists can better understand the human impact on climate change. The Antarctic ice sheet thus serves as both a guardian of the past and a warning for the future, highlighting the delicate balance of our planet's systems. Imagine the careful, methodical work involved in collecting these cores, teams drilling for days, often under harsh and dangerous conditions, handling the precious samples with utmost care to prevent contamination or damage. The tension and anticipation of each retrieval is palpable, as each core holds secrets that could deepen our understanding of Earth's climate story. Yet, these ice cores represent just one facet of Antarctica's multifaceted mystery. Beneath the ice, scientists have discovered a network of subglacial rivers and lakes, some hidden for millions of years. These aquatic highways flow beneath the ice, connecting distant lakes and influencing how the ice sheet moves. Mapping these networks is like uncovering an unseen vascular system, critical to the continent's stability. Recent technological advances, such as radar and satellite imaging, have illuminated these subterranean waterways, revealing their paths and the volumes of water they transport. The interplay between liquid water and solid ice beneath Antarctica creates a dynamic environment that defies the stillness we often associate with frozen landscapes. The discovery of these subglacial waterways raises profound questions. What ecosystems exist in these dark, pressurized environments? How have life forms adapted to survive without sunlight in water that might be isolated from the surface for millions of years? The answer lies in extremophiles, microorganisms that thrive in conditions once thought uninhabitable. These tiny life forms subsist on chemical energy derived from minerals in the rock and water, independent of photosynthesis. Their presence not only expands our understanding of the resilience of life on Earth, but also fuels speculation about the possibilities of life on icy moons in our solar system. Could similar ecosystems exist beneath the frozen surfaces of Europa or Enceladus, driven by geothermal energy rather than sunlight? Exploring these questions requires meticulous care and cutting-edge technology. Drilling into subglacial lakes without contaminating them presents an enormous technical challenge. Scientists must ensure that the sterile environment beneath the ice remains uncontaminated by microbes from the surface or drilling equipment. Protocols involve ultra-clean drilling fluids, sterilized equipment, and precise sampling methods. Each mission becomes a high-stakes endeavor, balancing the thrill of discovery with the responsibility of preservation. The suspense builds as teams await the moment when they penetrate the ice and access the hidden waters below, knowing that they might be the first humans to glimpse an environment untouched for millennia. But Antarctica's mysteries are not limited to its frozen depths. The surface itself holds clues to Earth's tectonic and geological past. Remote mountain ranges rise through the ice, their peaks known as nunataks, piercing the frozen expanse. These isolated rocky outcrops provide a rare window into the continent's geology, revealing the composition of ancient rocks and the scars of tectonic forces. Some of these mountains are remnants of ranges that once connected Antarctica to other continents before the supercontinent Gondwana broke apart. The study of these formations helps scientists piece together the puzzle of continental drift and plate tectonics, tracing Earth's slow but relentless transformation over hundreds of millions of years. Among these hidden ranges, the Gamburtsev Mountains stand out as an enigma. Completely buried beneath more than 2 kilometers of ice, these mountains were unknown until seismic surveys revealed their presence in the 1950s. Their existence raises questions about how such a massive mountain range could remain buried and preserved under ice for so long. Moreover, these mountains may have been crucial in the initial formation of the Antarctic ice sheet, influencing local climate and ice accumulation patterns. The sense of mystery surrounding the Gamburtsev Mountains adds to Antarctica's allure, an immense geological structure hidden from sight, still waiting to be explored and understood. Adding to the geological intrigue is Antarctica's volcanic activity. While often imagined as a frozen wasteland, the continent is home to active volcanoes, some of which lie beneath the ice sheet. Mount Erebus, one of the southernmost active volcanoes on Earth, regularly emits plumes of gas and lava. But scientists are now discovering that volcanic heat sources beneath the ice might be more common than previously thought. These hidden volcanoes generate localized melting, creating subglacial lakes and influencing ice flow. The tension between fire and ice beneath Antarctica creates a dynamic and dramatic landscape, one that challenges our perceptions of the continent as a frozen desert. This volcanic activity raises important questions about how it affects ice stability and global sea levels. Could volcanic melting accelerate ice loss? How might eruptions impact the subglacial ecosystems? These uncertainties underscore how much we still have to learn about the interplay between Earth's internal forces and its surface environment. The slow-motion drama beneath Antarctica's icy surface continues, a reminder that the planet is alive with forces both seen and unseen. As we reflect on these hidden wonders, the Antarctic continent emerges as a symbol of mystery and discovery. It is a place where the familiar is transformed into the extraordinary, where ice conceals liquid worlds, ancient mountains, and fiery heat. The very isolation and extremity of Antarctica preserve these secrets, protecting them from the disturbances of human activity and climate change, at least for now. For those who study this remote land, the sense of suspense is ever present. Each expedition, each discovery, peels back a layer of the unknown, revealing more questions and more mysteries. The allure of Antarctica lies not only in what is known, but in the vastness of what remains unknown. It calls to the curious, the adventurous, and the dreamers. It reminds us that on our own planet, beneath the seemingly empty expanses of ice and snow, life and history continue in silence and shadow. And as we listen to the faint creaks of glaciers and imagine the slow flow of subglacial rivers, we are invited into a story that unfolds slowly, patiently, like the ticking of an ancient clock. So, as you settle into rest and allow your thoughts to drift, consider the secrets beneath the Antarctic ice, a realm of silent rivers, hidden mountains, fiery hearts, and resilient life. Imagine the slow dance of ice and water, the microbial whispers in the dark, and the stories locked in layers of frozen snow. This frozen mystery is a lullaby for the curious mind, a soothing reminder of the wonders that exist beyond the reach of light and time. In the quiet and cold of the Antarctic, nature keeps its deepest secrets, waiting, watching, and inviting us to wonder. As we delve deeper into the mysteries hidden beneath the Antarctic ice, it becomes impossible not to be humbled by the scale and complexity of this frozen world. Imagine a vast, dark expanse stretching endlessly beneath kilometers of solid ice. A shadowy realm untouched by sunlight, where pressure builds, temperatures hover near freezing, and time seems to slow to a whisper. This is a place where life, if it exists at all, must defy everything we think we know about survival. It's a place that challenges the very limits of biology, chemistry, and physics, calling to those who seek to understand how Earth's most extreme environments function and perhaps how life might survive beyond our planet. One of the most intriguing discoveries in recent decades has been Lake Vostok, one of Antarctica's largest subglacial lakes, buried beneath more than 4 kilometers of ice. For millions of years, this enormous body of liquid water has remained sealed off from the surface world, isolated from sunlight and atmospheric gases. The pressure from the ice above keeps the water in a liquid state despite the frigid temperatures, creating a hidden aquatic ecosystem that has likely evolved in complete darkness and isolation. The thought that a lake the size of Lake Ontario could lie undisturbed beneath the ice, silent and secret, captures the imagination like few other natural phenomena. Scientists have long wondered what mysteries Lake Vostok holds. Is it home to unique microbial life forms that have adapted to survive in such an extreme environment? Could these organisms shed light on the origins of life itself, or provide clues to life's resilience under conditions similar to those found on icy moons like Europa or Enceladus? The quest to answer these questions has driven multiple international expeditions, each faced with the enormous challenge of drilling through the ice without contaminating this pristine environment. The stakes are high. One wrong move could introduce foreign microbes, irreversibly altering a habitat that has evolved in isolation for millions of years. The technology and protocols developed for this mission are among the most advanced and meticulous in scientific history. Drilling fluids must be sterilized to near perfection, equipment sterilized, and all operations conducted with precision akin to performing surgery on an alien world. Each inch of progress through the ice is slow and deliberate, with scientists anxiously awaiting the moment their drill bit finally breaches the lake's surface. When it does, they hope to capture water samples that might contain traces of microbial DNA, chemical clues, or signs of geological activity. The potential to discover life forms entirely new to science, extremophils that thrive without sunlight, feeding on minerals or chemical energy, is both thrilling and daunting. But Lake Vostok is just one of many hidden lakes scattered beneath the Antarctic ice. Recent radar surveys have revealed a network of over 400 subglacial lakes, interconnected by rivers and channels that transport water across the continent. These lakes vary widely in size, depth, and chemical composition, and each may harbor distinct ecosystems shaped by local conditions. Some may be salty, some fresh, some oxygen-rich, others starved of it. This diversity hints at a complex web of life and geology hidden beneath the ice, each lake a separate world with its own story. What powers these subglacial lakes and rivers? The answer lies partly in geothermal heat, warmth rising from Earth's interior, and partly in the friction generated as the massive ice sheet slowly moves and grinds across the bedrock below. This heat melts the ice at the base, creating pockets of water that lubricate the ice's movement and feed the subglacial hydrological system. The dynamic relationship between ice, water, and rock shapes Antarctica's landscape from beneath, influencing everything from glacier flow to seismic activity. Understanding these processes is crucial, especially as the climate warms and ice sheets become more unstable. Beyond the physical and biological mysteries, there is a profound sense of the unknown that pervades the study of these hidden worlds. Scientists often describe their work beneath the Antarctic ice as exploring a new frontier, a place where the rules of nature are tested and new phenomena await discovery. Each expedition brings unexpected findings, sometimes baffling and contradictory, fueling debates and inspiring new hypotheses. The slow pace of research, constrained by harsh conditions and logistical challenges, adds to the suspense. It can take years or even decades to confirm a single discovery, keeping the sense of mystery alive. This mystery is not limited to Antarctica's ice-covered lakes. Around the continent, the ice shelf fringes the ocean, forming vast floating platforms of ice that interact with the Southern Ocean beneath. These ice shelves are critical regulators of ice flow from the continent to the sea and act as buffers, slowing down the movement of glaciers. Yet, they are vulnerable to warming waters, and changes beneath the ice shelves could trigger accelerated ice loss and rising sea levels. The complex interface where ice meets ocean is an active research area full of unknowns and surprises. Scientists are uncovering intricate ecosystems thriving in these dark, cold waters, from microbial mats clinging to the underside of the ice to communities of fish and invertebrates adapted to extreme conditions. The discovery of life in these isolated and extreme habitats reshapes our understanding of what is possible in the natural world. It challenges assumptions about the requirements for life and opens the door to new ways of thinking about biodiversity and planetary habitability. The idea that life can flourish in darkness, under kilometers of ice, in near-freezing water, and under immense pressure, expands our concept of the biosphere. It also reinforces the urgency of protecting these fragile and unique environments from contamination and human impact. In the silence and stillness beneath the Antarctic ice, a delicate balance persists between ice, water, rock, and life. This balance is a dynamic one, continuously evolving over geological timescales influenced by internal Earth processes and external climate forces. The secrets held beneath the ice are vital, not just for understanding Antarctica, but for understanding Earth as a whole, its past, its present, and its uncertain future. The slow ticking of these frozen clocks reminds us that beneath the apparent stillness, the planet is alive and constantly changing. So as you lie down tonight, perhaps looking up at the stars or imagining distant icy realms, let your mind wander to the hidden worlds beneath the Antarctic ice. Think of the silent lakes sealed off for millennia, the ancient mountains buried beneath layers of frost, and the mysterious life forms eking out existence in complete darkness. Picture the intrepid scientists braving cold and isolation to unlock these mysteries, slowly peeling back the veil on one of Earth's last great frontiers. In that quiet contemplation, find a moment of wonder and peace, a reminder of the vastness and beauty of the world, much of which remains hidden, waiting patiently for discovery. Beneath the vast Antarctic ice, as you drift deeper into the silence and shadows, you begin to realize how much remains unseen and unknown. The ice sheet itself, this immense frozen ocean of white, conceals secrets that have fascinated explorers and scientists for generations. It is a natural archive of Earth's history, a vast time capsule holding clues not just about our planet's climate past, but also about the subtle forces shaping its future. Within its frozen layers, bubbles of ancient atmosphere are trapped, preserving a record of Earth's shifting climate that spans hundreds of thousands of years. Peering into these icy pages allows us to read stories of ice ages and warming periods, volcanic eruptions, and shifts in atmospheric composition. These frozen memories are as fragile as they are precious, and they remind us of the delicate balance sustaining life on Earth. But beyond these well-studied ice cores lies a realm even more enigmatic, the interface where ice meets rock, where water carves hidden paths, and where life might cling to existence in the darkest depths. The Antarctic subglacial environment is one of the most extreme on the planet, with crushing pressures from above, frigid temperatures just below freezing, and complete absence of sunlight. Yet, despite these challenges, evidence suggests that complex ecosystems could thrive in these conditions. Life, as we know it, is astonishingly adaptable, and the discovery of microbial communities in these isolated waters challenges everything we thought possible. These extremophils survive by harnessing chemical energy from minerals in the bedrock, using processes that mirror those found near deep-sea hydrothermal vents. They offer a glimpse into the resilience of life and hint at the possibility of life existing in similar environments beyond Earth. Imagine the pressure beneath 4 kilometers of ice. It's like carrying the weight of a mountain on your shoulders, pressing relentlessly. This pressure lowers the freezing point of water, allowing it to remain liquid at temperatures where it would normally be solid ice. This supercooled water forms vast lakes, rivers, and channels, creating a hidden hydrological network beneath the continent. The movement of water lubricates the base of glaciers, influencing their flow and stability. The interaction of ice and water in this dark underworld controls how ice sheets respond to climate change, with profound implications for global sea levels. Studying these processes requires sophisticated instruments that can penetrate the ice, sending radar waves and sonar pulses to map the hidden landscape and detect movement in real time. It's a bit like scanning an alien world, mapping valleys, mountains, and waterways concealed beneath a thick, frozen shell. One of the most remarkable features of this subterranean environment is its isolation. Subglacial lakes have been sealed off from the atmosphere for millions of years, creating environments free from contamination and external influences. This isolation makes them natural laboratories for studying evolution and ecology in extreme conditions. Any life found in these lakes would have evolved independently, potentially developing novel adaptations to survive in darkness, cold, and high pressure. The biochemical pathways used by these organisms might be entirely unique, providing insights into alternative forms of metabolism and survival strategies. Moreover, understanding how life persists in these extreme conditions can inform the search for extraterrestrial life, guiding missions to icy moons like Europa and Enceladus, where subsurface oceans may harbor life beneath layers of ice. Efforts to explore these hidden lakes have been met with both excitement and caution. The risk of contaminating these pristine environments is high, and scientists have developed rigorous protocols to ensure minimal impact. Drilling teams use sterilized equipment and carefully controlled procedures to prevent introducing microbes or chemicals from the surface. The stakes are enormous. A single mistake could irreversibly alter ecosystems that have remained undisturbed for geological timescales. The international scientific community recognizes this responsibility, balancing the thirst for knowledge with the imperative to protect these fragile worlds. As we consider the complexity and delicacy of these subglacial systems, we also recognize the limits of our current technology and understanding. Much of the Antarctic sub-ice landscape remains unmapped and unexplored. The dynamics of ice flow, water movement, and biological activity beneath the ice continue to surprise researchers. Advances in remote sensing, autonomous underwater vehicles, and molecular biology promise to unlock more secrets in the years ahead. Each expedition uncovers new questions. reminding us that the Antarctic ice is not a static, lifeless barrier, but a dynamic and interconnected system. Beyond scientific discovery, there is a profound philosophical aspect to this exploration. The frozen depths of Antarctica challenge our perception of life, resilience, and the interconnectedness of Earth's systems. They remind us of the vast unknowns that still exist on our planet and the humility required in scientific pursuit. The Antarctic ice is a symbol of both endurance and vulnerability, a majestic ancient entity slowly responding to changes wrought by climate and human activity. In contemplating this silent world beneath the ice, we confront the delicate balance sustaining life and the profound mystery of existence itself. So, as you settle deeper into sleep, imagine descending through kilometers of ice into a silent world lit not by the sun, but by the subtle glow of bioluminescent microbes, where ancient waters flow through hidden channels, carrying stories from the dawn of Earth's history. Picture scientists carefully breaking through the ice's surface, peering into dark waters that have never felt the touch of light, searching for life that might rewrite what we know about biology and survival. Envision the slow, steady pulse of the ice sheet above, shifting imperceptibly, but shaping the fate of continents and oceans. In this quiet reflection, find a moment of wonder and connection, a reminder that beneath the surface of the familiar lies a world still waiting to be discovered, as mysterious and vast as the universe itself. And if your thoughts begin to wander or your mind drifts into dreams, remember that you are part of a greater story, the story of exploration, curiosity, and the enduring quest to understand the hidden corners of our planet. Let the mysteries of the Antarctic ice lull you into peaceful rest, accompanied by the quiet hum of a world in motion beneath the snow and ice, patient and eternal. Sleep well, knowing that even in the darkest, coldest places, life and discovery continue, softly, silently, beneath the surface. As you continue your gentle journey beneath the Antarctic ice, it's impossible not to marvel at the remarkable technologies and bold human efforts dedicated to unveiling these hidden realms. Each expedition to the polar continent is a testament to human ingenuity, perseverance, and respect for the environment. The challenges are immense: bitter cold that can freeze metal in moments, storms that blanket the land in whiteout conditions, and the sheer remoteness of the region that demands meticulous planning and unyielding resolve. Scientists and explorers work together, often for months or years, developing specialized drills, robotic explorers, and sensors designed to survive and function in one of the harshest environments on Earth. One of the most ambitious undertakings in recent decades has been the exploration of Lake Vostok, the largest subglacial lake in Antarctica. Buried under nearly 4 kilometers of ice, Lake Vostok remained sealed from the outside world for an estimated 15 million years, preserving an ecosystem that has evolved in isolation. Reaching this